Hi, everyone. We are the Tracking Poverty team made up of Jawen, myself, Bettelhem, Isan, and Elliot, and our project lead was Jenny, and our data scientist was Jessica. So we're going to just give you some introductions and then go into the two approaches that we did, looking at one looking at multiple definition at 1 month, and then the other one looking at time, looking at one definition across time, and then looking at and then ending with future work. So our purpose was building households and families out of individual level data. So why do we care about households? Let's say we have two individuals. One has an annual income of $15,000 and the other one has an annual income of 100,000. If they were unrelated, one would be under the poverty line and the other one would be considered non-poor. But if they were related, they both would be considered non-poor. Poverty is a household level construct. It looks at pooled resources. So when you think about questions about poverty, we're thinking about who is sharing those resources. And this would allow us to answer questions such as like the impact of the Seattle minimum wage, which and its impact on the poverty rate, which is one of the longer term goals of this project. So what is a household? A household's defined in many ways. The census defines it as a people that occupy a housing unit, and they can be related or unrelated, but kind of puts it into two categories of family and non-family households. Additionally, we found when we were like looking at different organizations, one defined it as people that buy groceries and cooks together at a residence. So it's really nuanced definition across people. And then socially, there are like our age, our marital status, our immigration, race, class really influence how we think of our own household, our family. So our goal was really to think about how can we get to a point of this is a resource sharing unit or economical unit that really represents as much the complexities of society as possible. So here we're looking at residence as a physical household, family is like a relational household, and household as defined in multiple ways across the spectrum of residence and family. So we use the WMLAD or the Washington Merged Longitudinal Administrative Data Set, which was created to examine employment and earning outcomes. And it got information from across 6 state agencies about 10 million people across 96 months. And it was not collected for research purposes. And that's something important to know. And it also like some agencies cover some subpopulations more than others, but collectively they give us a really it was very informative for us to know who was in the data and also consider who else was missing from the data as we went on to do our analysis. And then on the second section, we looked at previous work by Jenny and many of her colleagues, and when they looked at, like we focused on these two that they looked at, which were the recorded addresses, which looked at sporadic address records from months that people interacted with the agencies, and then used that to create estimates and replace the missing addresses across the 96 months to get more the likely or imputed addresses, which we then used as our like starting point to kind of improve upon using two different methods, the point in time and the longitudinal method. So while we were doing this, we had to recognize these are people that we are talking about, and we were always trying to think about the ethical considerations with using administrative data. We were always trying to think about what are the different definitions that would consider the atypical households as best as we could, as well as thinking about using the enclave and layers of anonymity to maintain security and privacy of the data, and then thinking about having detailed documentation and holding ourselves and each other accountable to use this data for public good, but as well as like consider this is people that we're talking about. So this is like what we saw in week 2. There's a lot of like the whole like big chunk of the summer we just used to try and understand what was there. We had some guidance, but really we spent a big chunk of it trying to understand what the structure of the data sets, distinguishing between the important variables and non-important, like for our purposes. And then from that, we kind of created a schema to really pull out the ones what we wanted to focus on, which was focusing on demographics, the imputed address codes, last name codes, and like social services, and kind of just looking at the relations between them, get rid of redundant information, and then cleaning the data, and then putting this into a database that we could use to look at households as well as feature people can use.
All right. So we took 2 main approaches to creating households. The first we called the point in time approach. And in this, we consider just 1 month of data at a time. and we add on one variable at a time. And at each stage, we subtract out the households that are clearly defined enough, and we don't need to consider them anymore. So we started with address information, and then we considered last names in two different ways. And after I talk about that, Jawan will tell us about our longitudinal approach, where we consider address information over multiple months. So we take our population and we start by grouping them by address, both the recorded addresses and the imputed addresses. And when we do so, everything becomes more clear. In this case, you can see 5 people share an address identifier in our data at a given month. And our first definition uses this residence as its only input, and the output is that it's a household. So this sort of follows the census definition, where people who live together are a residence or household together. And this actually is the basis for our other definitions, in that only people who live together at the same time can be a household. The census works this way, and so do the rules for different anti-poverty programs that we have data on. But what this definition doesn't capture is, are these people roommates or are they family? If we assume that they pool income together, we could miss some people living under the poverty line. So we want to get closer to measuring a family, or more accurately, a resource sharing unit. And to do so, we try to infer relations from the data. One limitation of this, we are looking only at a single address at a time. And so we're not identifying resource sharing with dependents who live elsewhere, even though we know that that takes place. But instead, we're dealing with cases where people live together and may not be sharing resources. We have limited data options to choose from here. We don't have marriage licenses or much information on children. And we have to be really careful with using demographic data like race and sex, which covers almost everyone in our data set. But inferring relations based on these categories would just reinforce heteronormative, racially homogenous traditional family notions. So instead, we look at last names. Why? If people share a last name and they live together, we're pretty certain that they're family. And we have one in our data for almost everyone. We also found that 63% of the naive households have only one last name. This does include people who live alone, but it's still a pretty large part of our data that we were able to take out of the picture. So now we see we have 2 clear cases. There's one last name in the residence, or there are multiple. For the first case, we preserve the naive definition and we consider them completed, which reduces computation time in our further exploration and decision making. For the second case, we take 2 approaches. The first is deterministic. And in this approach, we split the multiple families up at the single residence into separate households by last name. However, we know that many families have multiple last names in them. So to address this, we use probability to decide between the 2 options, keeping them together or splitting them up by last name. And we do this with a weighted coin flip. We weight the coin based on the census likelihood that a residence is a family or not, by household size and region. For example, in this case, we would look at 5-person residences in counties A and B, and maybe county A has 80% of them as families and county B has 20% as families. So those are the weights for the coin flip. And we could get a lot more granular with these probabilities, incorporate age information and census microdata, tailor to more specific cases with the number of last names in the household. But this is as far as we got, and the code is set up so that it's easy enough to adjust these probabilities in the future. And here's a quick recap of our household definitions. We have naive co-residence and last name definitions, both deterministic and probabilistic.
Thanks. Hi again, this is Ihsan. So sorry for your eyes to making you look at the table with a lot of numbers. It's my bad. So what we're gonna do today, right now by my section, I'm gonna show you some of the distribution of how households differ based on our definitions, and we're gonna compare the census data. But I need to tell you that there's not an actual grand truth comparison for this kind of research. So we can test certain definitions. Certain definitions do well on this kind of comparison to census, certain does not well. The whole idea is depends on your research question, and the way you want to calculate poverty is which definition or what type of way to look for. So in this case, we only compare census. I'm sorry, I have to repeat. So this is for all Washington states, for all families, all households, whether a family or a non-family, and their distribution across household size, 1-person families, 2-person families, to 7 and plus more. The reason for 7 plus more is just came from census. And so in order to make the comparison, we have to lump them into the same category. So what we understood is here. So if you remember the method, if you remember the methods, the name co-residence, basically putting people who live in the same time and address into each other, this should make the census process as close as possible. But the problem is here, as you can see in the first household size, we have overestimated these people in terms of percentages. And the reason for that is most likely we don't have the children data. Here's an example. We see a 1 person, maybe a single mother with a child that we don't have in the data. We think they're a 1-person household, but in reality, they might not have to be, or they might not be. But in general, as you can see, and especially in larger household sizes, the percentages are a lot closer and the counts are a lot similar, especially this is like very similar in 3-person households. I don't know an exact reason why 3-person households are like better off than 4, probably just chance. But as the number of household sizes increases, these numbers, so you see the drawbacks, pros and cons. But as Elliot mentioned, the other thing we need to decide, okay, we can divide people into smaller groups, but how can we decide whether they are families or resource sharing units or not? And that's the second comparison. And this time, instead of looking at, unlike here, the all family and distribution of across sizes, we are looking at the census, I'm sorry, I should have said decennial census 2010. Census is not one thing. There are a lot of census data. It's US, because our data covered from 2010 to 2017, the only decennial census data with exact counts but not uncertainty came from 2010 census tables. And moving on, we look at the family, what census called family households on the first axis in here. So these are the percentages of, and that's why we don't have a 1-person household, because census doesn't label 1-person households as families. And the first thing, if you remember, the last name, if you just disaggregate co-resident people who are co-reside, staying together in a given month, you will have a lot of 1-person or sorry for the echo, 1-person family is going to pop up because you don't know you haven't done anything with them. But that has some advantages that you will never, at one point you will get very granular, but at the other thing, you will probably miss a lot of people who can be a family but not share a last name. So the good thing in here, when you take just the mere tract level, tracts is a geographic unit, is smaller than the county, but bigger than the neighborhoods. You can refer them as blocks, neighborhoods, so it's bigger than neighborhoods. And you can reduce the discrepancy, and you can have a better distribution, and they can match better. And and even this simple taking up the probability, adjusted probability, once you label the ones that you already know of, the numbers match slightly better. And this, but as you see in here, as the size increases, and as you can also see in here, as size increases, what you see in here, you take 1 or 2 people households, probabilistically you put some of them as higher families. Actually, we're not putting them in here. We put them non-families, but the ratios change so that you have a better distribution. Sorry, I should have been more clear about it. But the case in here, what happens to 1-person families? We will have much more discussion when Javan talks about, but I want to show you an evaluation of this. This is Seattle metropolitan area. And this is, so this map shows you whether we overcount represented as red, whether we undercount. Right, okay. It's kind of weird. Whether we undercount based on blue. So the color should be the reverse order. I'm sorry, I was confusion. And we have some form of a vague confidence interval. Basically, if we miss between 2.5% below and above, we count it as, we say it's within the error range. So you see them as white. And in most of the Seattle, you can see that they're red. So we overcount 1-person households, which makes sense because I have to remind you, this is for just co-residents, and this makes sense because we have missing data on children. But when you go back to the downtown Seattle area, where we know that from census, we know a lot of 1-person households leave, we are undercounting. Even with a definition that we hoped our count than undercount, we are still undercounting in the one-person families in the downtown area. And this where we see the likeness of one point in time approach, and we will introduce you why we should look at this problem longitudinally.
Additionally, we look beyond point in time and incorporate longitudinal household changes to improve our imputed addresses. To begin with, we compare the distribution of households by size using census and our naive co-residence from Womenland dataset, and found that we overestimated one-person residences and underestimated the others. To explain why this happened, we looked into specific scenarios regarding these one-person residences. In the first scenario, we observe one person living alone for a few months and then start to live with others within the same address. This is likely to happen when the added person is a child who interact with government agencies less frequently than adults. For example, only when the child registered to vote or get their driver license would they leave an administrative record into our data. In this case, we want to make a revision to reflect reality. For the second scenario, we observe alternately appeared pattern of one-person residences and the other multi-person residences that the person belongs to. We believe that these frequent movements into and out of the same address are likely to represent an imputation error, and we want to revise these one-person residences accordingly. For the third scenario, we observe two persons living together for a few months, and then they start to separate from each other and reunite again in a new address. We believe this corresponds to the case where members of a household move out at the same time, but their addresses were not updated accordingly. In this case, we want to pool these one-person residences together in the transition period. However, here is a case we don't want to make a revision, which is when the two persons who used to live together for a few months, and once they move out, they no longer live with each other. We want to leave their observations as they are, which means we only want to make a revision when the co-residence before matches a co-residence afterward. Taken together, we want to revise the one-person residences, taking into account the following scenarios: lack of interactions, imputation error, and moving in and out. After implementing this modification algorithm and removing duplicates to make sure that each person only appears once in a given month, we found that the proportion of one-person residences went down to 31%, which looks closer to the census data. So to summarize what we have done throughout this program, first of all, we created a relational database for future Womenland users with all data in a clean and well-structured format. And we also applied both point-in-time and longitudinal approach to derive and improve household and family identifiers. We believe our workflow and data output can be used for future researchers to answer questions at the household level. And admittedly, our work is subject to some limitations. One of the limitations is that we only applied the longitudinal approach to households of size 1, and in the future, we hope to extend the logic to households of larger sizes, while integrating point-in-time family information and longitudinal corrections. Moreover, we hope to incorporate other information such as social networks, demographics, and anti-poverty programs to capture a diversity of households. In the end, we want to thank everyone that supported us and our work throughout this program, and we look forward to your feedback.